Okay, final part, question 2. Question C this time. It's asking us which, again, same organic compounds, but this time which ones are going to react with ethanoic acid in the presence of concentrated sulfuric acid. So presence of concentrated sulfuric acid is probably a catalyst in that reaction. In this one it is. It's taking an acid, carboxylic acid, and reacting it with the previous 3 compounds. Now, the identifiable organic compounds that will be made will be esters, and so we need to react that with the 2 alcohols. The aldehyde part of that molecule won't react with ethanoic acid, so we're going to be undergoing an esterification type reaction, and we need to give the structure of the organic product. So we're going to need to form the ester bond. So we're going to create the butanol compound first of all, the straight chain butanol compound. That's going to take the straight chain part of the alcohol. It's going to remove the hydrogen. It's then going to bond that to the carboxylic acid end of the ester, the ethanoic acid, and give us that type of structure. Okay, likewise with the tertiary butyl one, it'll do a similar type of situation whereby the carboxylic acid bonds to the alcoholic part of the alcohol, and it will give us this tertiary butyl based structure there. And for the final question then, it's asking us just to do some NMR. But this time it's not asking us for analysis of the peaks. This time it's just asking us for the sheer number of peaks that we have in the compound. So this is looking at the different number of chemical environments. So for the first one, we've obviously got a CH3 on the end. That is going to be slightly different from the CH2 next door, which is going to be slightly different from the CH2 next door to that. And likewise, the difference is going to get merged on the spectrum, so it might be a slightly messy looking spectrum, but ultimately there are 5 types of proton in that molecule. And in the tertiary butyl type structure here, if we take the ester down below, we can see that we've got some symmetry about this carbon here. If we obviously remember that we're looking about the alcohol version here, but the tertiary structure here means that these 3 CH3s around this central carbon are equivalent, and so these 3 methyl groups would all be equivalent, would only give 1 peak. We'd then have a second peak for the OH itself. So for that one, we would have 2 peaks. Obviously, we don't need to look at the splitting. For the tertiary butyl, the splitting would actually be relatively straightforward. For this one, we'd have quite a lot of mutual splitting from left and right, so that one's going to be a bit messy. But the number of peaks for the butanol compound would be 5, and for the branched butanol compound, that would be 2.